Howdy champions, how are we? Today we've got an orange AD30 twin channel amp. It's a combo. This is the chassis removed. It's an interesting amp actually. It's got two fully independent preamps, even up to the phase inverter. There's a different long tail pair per channel, which is kind of strange to me. They've got identical values. The only difference is the value of the coupling caps driving them, and I don't know why you wouldn't switch it one stage earlier and save yourself a tube, valve, whatever. So this one's come in with a few weird noises, those kind of issues. It's got some pretty heavy evidence of heat damage to the EL84s, which you can see there. They're proper cooked. So we'll fire it up and we'll check what state they're running in. But first and foremost, I've already checked the fuse values, that kind of thing, all the essentials. It's got a couple of missing knobs on the front, but we'll first, before we tear anything down or replace anything, we'll just switch it on and determine what the actual fault mode is. Plug her in there. Put the, not the dummy load, put the test cabinet in. Speaker jack's a little bit loose there, but it's the insulated type anyway. And we'll fire it up. Just warming up. Channel 1. Set everything at noon as usual. On both channels. We'll just check, because it's two independent preamps, we'll have to switch between the two channels, see if there's a issue that's channel specific. So this one's got the 5AR4 rectifier valve there. Big chunky power tranny for a 30 watt amp, cathode biased, and sort of mid-size output tranny. You can see there's two patterns of holes. See those holes? They're threaded inserts. So they must have had two different trannies available for this one, two different transformers, and they've made the allowance for the larger one. That can be smart if you're not 100% sure of your supply chain. Alright, so let's switch it on. I'll just turn the masters down for now in case it oscillates, it does anything wild. There's a bit of hiss there. Nothing too dramatic though. Ooh, a little bit of crackling on the gain pot there, but there's no knob on it. So the crackling is occurring because the body of the pot is intermittently grounding to the shaft, excuse me, which I'm holding onto in my hand. So if we grab a rag or something, a bit of plastic, and I turn to the same knob, it doesn't happen. So that doesn't necessarily mean that you've got a crackling pot. It just means it's intermittently grounding the shaft, and you won't have that issue when the knob's installed. So no dramas there. Flick over to the other channel, turn that master down again. This one should be a bit noisier. I think this is the higher gain one. No, it's quieter. It's channel 1 the high gain. There's almost nothing there. That could be an issue. Back to 1. So pretty noisy, but that's maxed out. Let's have a quick listen for any microphonics. A little bit there. So that's that channel that we're on. channel 2. Crank her up. Oop. So it must be the low gain channel, channel 2. A little bit of rattling there. Not great. So those EL84s are a little bit microphonic, but there's crackling and a little bit of weird oscillation happening there. Could be dirty pins, but either way, those valves are cooked and the customer is pretty keen on a full new set. They're the stock. What are they? Electro Harmonics. Yep, made in Russia. I think they're Chinese 12AX7s. So he's pretty keen to just do a full new set of JJs and start afresh and go from there. So I've just power cycled it a few times, and it looks like this EL84 here is the noisy one. So when a power channel output valve is becoming microphonic, it's an indication that something's coming loose inside. Possibly one of the grids has a loose winding on it. Either way, they're getting replaced. Alright, so we've flipped her over. It's a pretty well constructed amp. It's got some, you know, mass construction techniques, but it's a well thought out, spacious circuit board considering what it's got in it. And nice big pads, through plated holes, dual sided board, and reasonably chunky copper tracks on it. So all pretty good. Now the owner brought this in because he opened it up and saw the top of the main filter capacitors bulging. Now he assumed that that meant the capacitors were failing, but these ones here in particular, Samwars, they have a little plastic disc on top. Now the plastic wrapping that's around the capacitor over time, particularly with a little bit of heat, shrinks the plastic and it increases the tension on the edges of that little disc on the top of the capacitor, and it eventually deforms the little plastic disc because it's pretty thin plastic and makes it dome up. So it looks like the capacitor's failing, bulging at its end like they do, and normally the pressure relief cuts would let go like in these Nichicons and pop open and relieve the pressure so it doesn't explode. But you push the disc down and you can feel underneath that the top of the capacitor is actually flat underneath. Now that means it's been exposed to a little bit of heat, but that doesn't necessarily mean that it's outside the spec of the capacitor or that the capacitor needs replacing. However, being Samwar and not particularly good quality, the owner wanted a full recap anyway, just to start with good quality caps. He loves this amp and he wants it super reliable, wants it to be his one and only, and wants some 105 degree caps in there, long life if possible, say 5,000 hours if we can get them, and just good quality with a good chain of custody. And well, we've got the board out, we'll inspect to see if there's anything else that needs attention. Of course, while I had the camera not rolling, as happens, it made a horrible noise, so that was tapping around this area. So that could be the socket requiring, Jesus. I've got a lockdown brain. We've been in lockdown since June, so I'm not used to talking at all. I've got my lockdown beard too. I'm going to shave it off when we can go to the pub again. Anyway, so yeah, made a horrible noise. Could be one of these spade contacts, although they feel reasonably tight. Very thin wire going to the transformer there, but it's probably 600 volts rated. But it could also be an internal fault, and that was that slightly noisy EL84 that I was tapping on at the time too, so I'd say that's probably the valve on the way out. Hasn't blown any fuses yet, which is positive. One thing I'm noticing though, they put hot melt glue on parts and it's melted and it's run down the amp. I still don't know why people use hot melt glue on valves, particularly hot running cathode biased amps. It just melts the glue. So silicon would be the thing of choice there, or just rely on your solder joints. But here it's got quick connect little headers for each heater, so that speeds up and elevates the wiring, speeds up the construction as well, and you don't have to have the high current traces on the board and keep them away from the audio traces and signal path. And that's a pretty quick and easy way of doing it. But yeah, everything's got its issues. There's a funny little arrangement here where they've thrown another cap in and 2 extra diodes. So something has been revised on the fly there. It looks factory. I don't think anyone has been in this thing ever. There's just a few little mods where they've got like series resistors, but it all looks like it probably was factory revisions, and they didn't want to, or they wanted to use up their old circuit board, so they just do a few bodges to make it all happen. All right. So that valve has microphonics coming in and out as it gets tapped. It's almost like the, I don't know, like the screen grid. One of the coils is touching and then letting go of the actual support post that it's supposed to be spot welded to. There may be an intermittent connection inside there as well, or possible arcing, because every now and then it does that. I'm never ready for it. So yeah, there are issues. Being a combo, this would be triggered by having the speaker right next to it, and that would be doing some pretty weird stuff when you're playing at high volume. Possibly, if it's been switched on for a while, it might do weird stuff at idle as well. So that's why the guys brought it in, and he's assumed, I think he assumed that might have been the caps on the way out, but it looks like it's the one of the EL84s. So the dissipation's not out of control. It's sitting at around 100%. I'd like to have it a little bit below that, but the plate voltage isn't ridiculous compared to that DC2 that I just had. So it's not abusing the valves as much as most amps, so it should be reasonably reliable. The only thing that I might consider doing is increasing the screen grid resistance, so the screens aren't dissipating as much under hard overdrive, because this thing's only a 30 watter and it gets cranked fully up from talking to the customer. He likes that wide open rock and roll sound. So it's currently got 220 ohms per valve, so I'll probably go up to 1k, and 2 or 3 watt resistors, probably 3 watt. They've got 4 watts in there at the moment. See those strange vitreous enamel coated things. So they're a little bit tricky to get to, but we've got to take the whole board out anyway, so I'm just going to disconnect everything, pull all the valves out, and hopefully leave the front panel on. Although I might remove that just to give the pots a clean as well, because half the pots are mounted on the top and the other half for the other channel are mounted on the bottom, so you've got to access both sides of the board to give them a good clean. And then we'll replace the caps, in case I didn't say that already. We'll go from there. Now when you're working on an amp, it's a little bit like going on a camping trip. You've ideally leave no trace. No one should know that you've been in there before, if possible. And if you have left a trace, make it better than it was when you turned up. So these screws, they're posi drive. There you go, posi drive number 1. So if you use a Phillips number 2, Phillips 2, it sort of works. They sit in there, but you've got to push pretty hard or it tries to strip the screw out. And if you push really hard on all of them, you probably could take them out without a trace, and they are black screws, so they'll be pretty obvious if you've reamed the head out on one of them. But just get the proper tools. So that's a replaceable, well, you know, a handle with a 1/4 inch hex receiver to take these kind of bits, and then just get yourself a kit of those bits. The bigger the merrier. And this is Posi Drive 1. Insert. So it's like fillets, but it's got extra little ribs between the whatever you call them. So that, when I put it in, it just sits there and it's locked right in. It's a perfect fit. You don't have to put much pressure on it, and the screw comes out. You don't even know it's ever been removed. Right, so I've gotten all the screws out from the chassis, so the standoffs will come out with the circuit board, just so I can slide everything out and there's no obstruction. One screw I couldn't get to on the other side, that's where the transformer is. I'm not taking the transformer off because I can't get to those bolts either, but I wouldn't do that anyway. So I'll just take out that single screw from this side. Alright, so we've removed the board, as you can see. We're just having a quick inspection of the bottom just to check all the solder joints are sweet. One interesting thing, just there, right there, there's a little defect in the solder mask, and someone's actually gone over that by hand. You can see there in the light with some conformal coating. So that goes to show that the board's been inspected by a human. And they've actually taken the time to go over and repair anything that wasn't perfect. You can see where the thing was probably, I'm guessing it was wave soldered, and then the sockets were hand soldered after. You can see they've washed off the flux residue. There's a little bit left there still, but the fact that they've actually washed it. Don't ask me why this camera likes focusing on the background. Stupid friggin' thing. Anyway, yeah, it's 2021 and we still haven't figured out how to make cameras focus yet. Give us another 10 years. Anyway, so yeah, everything appears fine. There's two little joints down there that appear to be hand soldered. The solder's a bit shinier than the other stuff. It may be leaded solder, whereas the rest of it's lead free. It's got that sort of milky lead free look to it. But overall, I don't think anything here is the culprit of that noise. Some 60/40 solder here. Don't use unleaded for repairs. Got the boffer fume extraction, so I'm not breathing in the flux. Just get some fresh solder on there in order to take advantage of the flux, because they clean it off after soldering in the factory, so you need something to protect the solder joint from the atmosphere, otherwise it just goes all cheesy and gross and clogs the desoldering gun. Just clogged anyway. There we go. New ones are installed, just soldering the joints. Don't get too much solder on there, but make sure that it flows down into the joint. Then we trim off the excess. So here I've got the new screen grid stoppers. Oop. They're 1K 3 watt metal film. So we just gently bend the leads. Don't want to bend them too sharply. And then, because we want a bit of airflow around them, I use my forming pliers, and they put a nice little kink in the leg. Like that. So now when we insert it, it'll only go up to that little kink, and then we solder it, and that keeps them a consistent level above the circuit board to allow airflow. Right, so now we've got our new screen stoppers installed. Just straighten them all up. Just bent our leads over at the back to hold them in place. We're gonna flip the board back over and solder them down. Put the boffer back on. That'll help hold the board in place too. Go through and solder the rest of the caps. There we go. Snip off the excess wire. Turn off the boffer. I like to just get all the ones pointing away from me at once, instead of shifting back and forth, you know, doing the dance. And get the other ones pointing towards me. Now we'll apply a little bit of isopropyl, not so much that it pours off, but enough that it'll sit around the solder joints for a little while before evaporating, just to soak into that flux, help us remove it. Oh, missed a wire there. That's the component leads, just trimming off the excess after. Now, leaving flux on there is not the end of the world. It used to be way worse when the old fluxes weren't really chemically stable, and they'd corrode component leads and just get real crusty and hard and turn to like black coal after a while. The fluxes these days are designed so you can leave them there, but I like to remove it anyway. Just that thing I was saying earlier about leave no trace, like you're camping. Just make it look like it's that good, if possible. Sometimes there's no option, but you've got to make some modifications if the amp's really buggered. But just try and make it look like it would pass QC at a production shop. You don't want people opening it up and seeing big gobs of black and dark brown flux everywhere. And it's handy when I open an amp that someone else has worked on, and straight away you can see where they've been, because there's big puddles of flux. Whereas they clean all that stuff off in the factory. If they clean it off in the factory on good quality amps, you got to question, you know, maybe we should do it too. And you'll find the cheap crappy amps, they'll do anything to avoid a step in production, so they don't clean it off, and the boards look terrible. It just looks like a low quality bit of gear. So that's why I clean it off. Rightio. So we've got the boards back in, everything's reconnected, and we've got all new JJs except for the rectifier. We're leaving the rectifier in for now. These EL84s, the stock ones, which are Sovtex, Electro Harmonics, 6 week of 05. So they've gotten very warm. You can tell there's discoloration all over the glass. It's like the mica has been off gassing. It's gotten that hot. Now these were in tall tube shields, valve shields. They're typically to protect from electromagnetic interference, and you'll find almost on every amp they've got them on the preamp valves, or select ones, the most sensitive ones at the start of the circuit. Sometimes all of them to protect them. These had them on the EL84s as well. Now that prevents airflow. It gives it another layer of insulation between the glass and the aluminium, a pocket of air that's not moving, that prevents the valves from cooling down. So we're going to leave them off. Looks like one of them's either copped a hit or it's probably just from manufacturer actually. But yeah, we're going to leave them off because the valves, they're very lightweight and they're pretty stiff in those sockets anyway. So I think we're going to be fine with that. And worst comes to worst, if that presented any problems, we could put the little wire retainers, but they're not coming out. They're going to be fine, and that'll allow more airflow to keep them cool. Okay, new valves installed. We're sitting at around 105% dissipation on the outputs. It's not the end of the world, it should be around 95, but what's 10% between mates? Especially when most amp manufacturers seem to run somewhere between 120 to 130 these days with high play voltages. Plate's sitting at 320 volts, and we've got 12.5 drop over each pair of 150 ohm cathode resistors. Sorry, that's one 150 ohm cathode resistor per pair of valves, and each one of them is dropping 12.5 volts, just to be correct. So all the microphonics are gone. There's no popping or crackling or anything that was happening before. We gave all the valve sockets a clean. I used a toothpick with some alcohol to clean every individual pin socket, and the new preamp valves are a lot quieter. That's cranked all the way. They've got to be some of the quietest valves I've heard actually. It's a bit of a lucky dip, but yeah, they're really quiet. That's good. And no other evidence of crackling or popping. What time is it? It's 3 o'clock. God. So now we're just going to clean up the pots a bit, which requires powering it down again, draining the caps, and just removing these boards and giving a bit of a cleaner lube. They're not too bad. They've cleaned up a little bit just by cycling them. A little bit of crackling there though. Can't hurt to clean them up. So we'll do that, and then we'll see how much power she's pumping out, and write up the job sheet and put her out the door, and she's good to go for another 10 or more years. So we're just giving it a quick sound test. So that's channel 1 set with a reasonably clean gain. So then we want to see what the output stage is doing when we push it hard with the clean tone. That's nice. I hope that compressed good there and didn't deafen you. So there's no hint of oscillations or anything weird, any strange breakup which might be indicative of maybe arcing inside the valve or anything weird like that. So so the output stage is copping it sweet, which is what we want. We'll turn the gain up on channel 1, so all the way. And then we'll bring the master up a bit. Just humming there because I'm right next to the power transformer with the pickups. So that's all preamp distortion at the moment. A bit smoother, a bit more, bit warmer. All the EQs set 12 o'clock, set to noon at the moment. So we'll set. Let's just compare the sounds of the two channels. We'll set everything at noon, except for the masters, which we'll set a bit lower so we don't blast the camera with distortion. So that's channel 1, channel 2. Channel 1 again. Channel 1's got more bottom end. Channel 2 is it's had the bottom end taken out of it a bit. Looking at the circuit would explain that, but it's got more gain on channel 2, and channel 1's a bit warmer. So let's clean up channel 2 a bit. We'll do the same thing because it's two independent preamp signal chains. We'll just make sure there's no dramas on that when we push it real hard as well. So that's more or less clean. Bit of break up there. That's sort of like where I like to sit when my volume's about halfway. Just on the edge of break up, and then you can use your knob on your guitar, your volume knob, as the gain controller really. That's just me using the volume on the guitar. Set that halfway. So then we bring it up a bit further so we've got some healthy rhythm distortion. And then if you want to do a solo, you just use your volume on your guitar. You don't even need a foot switch. I really like amps that sit in that nice little sweet spot. It's you can have a single channel amp if the gain structure's designed properly. It's a really versatile amp still, even though it might only have like 3 knobs on the front. None of this Mesa Boogie 20 knobs a channel situation. It's just a well-designed preamp, and I tend to prefer the sort of British sounding designs like the Oranges and the Marshalls, and they suit me anyway, but you know, it's a taste thing, whatever. Yeah, it sounds like this thing's performing fine. The noise floor is reasonably low, a little bit of hiss there when you push it hard. More so on channel 1, which is strange, being lower gain. You'd think it would have less, but I'll check the circuit there and just check the pot values and stuff. That might be the difference. That is flat out though, which isn't a real practical use case for the channel 1. So then channel 2, flat out. Yeah, there's a fair bit of hiss there too. You can hear there's less hum on channel 2 because it's got some filtering in the bottom end by virtue of the I think the bypass cap values or the lack thereof in the first stage. So the channel 1 having more bottom end will naturally have a little bit more hum as well. Being picked up because I'm right next to it with the guitar, but yeah, I'd say that's cool. So next we'll fire it up through the dummy load and just take some actual measurements of the power output. And I've got to put the knobs back on the front, clean the front panel first, clean the knobs individually because they're pretty gross, and clean the cabinet and put it back together and send it out. Right, so just to demonstrate how we test the power output of an amp, just to check that it's putting out the rated wattage or thereabouts. Manufacturers tend to exaggerate either the RMS output or at what percentage of clipping that quoted power output is happening. So here we've got our function generator, an ancient Australian made one actually, made in Melbourne, BWD Instruments. We're giving it 1 kilohertz or thereabouts, sine wave. That's coming through the cable here, plugged in the front. We're going into channel 1, and then we've got the output across a 8 ohm load. We've got the waveform visible here, no signal yet, and that's the RMS AC volts across the load. This is a Tektronix 2236, which has got a multimeter built in. That's that top row of switches up there and that readout. Very handy, and it's good having it just attached to the load, so I can take both measurements at once without having to attach a multimeter and whatnot. So let's crank her up. You can see the waveform coming up there. And you can see it top and bottom leveling out a bit there. Sorry if it's a bit blurry. So that is happening at 15.7 volts. So we'll bring that back down again. Might just leave that at about 2 volts for a bit, just check that everything's stable. Bring that up and see if there's any fuzzy bits or anything weird. But that checks out to about 30 volts. So 30 watts, sorry. So we want to go, what was it? 15.6 squared Ohm's law divided by 8 ohms load, and that gives us 30.42 watts. So she's putting out almost bang on 30 watts. So she's happy. Woohoo! Cleaning out the cab. Yummy. It feels like felt. Try and get the big chunks. Baffle, the vertical surfaces still get stuff stuck to them. The baskets are quick clean. I'll give it a brush with some compressed air in a bit. There, it's already 10 times better. There we go, that's much nicer, isn't it? Even gave the baskets a quick wipe and the magnet. Looks like new. Give the panels a bit of a clean with my favourite cleaning stuff, Nifty. Unfortunately it doesn't come in 5 litre bottles. Don't want to get it everywhere, just don't want to soak the thing. Just enough to get the embedded dirt out of the Tolex. Makes it look like new. part of the AMP day spa treatment. Just a slightly damp sponge, get off the excess. And give her a dry. And repeat to all the other panels and the cabinet itself. And there she is, champions, all nice and shiny and clean. Back covers back on, speakers plugged in, new knobs installed. One of them, I ordered 5, I needed 4. One of them had a missing spot, indicator dot. Lucky I ordered a spare. So yeah, ready to rock for another 20 years. Thanks for watching, champions. See you on the next one.